Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to our YouTube channel Paper Vault, where we are solving past paper questions for physics, IGCSE. Currently we are solving paper 2 and we are doing this according to the topics. So basically Paper Vault is providing you solution to your topicals. We've already done 5 topics. Start today with our topic, that is forces, and we will be doing paper 2 questions of based on the topic of forces. Before we start, kindly like, subscribe and share the channel. If you have any problems or any questions, kindly comment below, and if you find any of this helpful in any way, kindly remember me in your prayers. Thank you. So let's start. Bismillah ar-Rahman ar-Rahim. Question number 1. A train is traveling horizontally in a straight line. A book is on a table in the train. The diagram shows all the forces acting on the book. How is the train moving? Accelerating to the left of the diagram, accelerating to the right of the diagram, moving at uniform speed to the left of the and moving at a uniform speed to the right of the diagram. Okay, let's see. Now the image states that this is the contact force in the upward direction. The weight of the book is in the downward direction. Frictional force is towards the right, and we need to tell by looking at this diagram that where is the how or where is the train moving. Okay, now we can always say that the upward force and the downward forces are balanced. Okay, but the frictional force has to have a force in the opposite direction as well. Okay, now we already know that friction acts opposite to the direction of the motion. Okay, so if this is the direction of the frictional force, then the book would be moving backwards. Okay, once we've established this thing, we can now see or take a look at the bigger picture. Okay, now if the train was moving at a constant speed, the book wouldn't have moved backwards. है ना? If the book is moving backwards, it's because the train is moving faster than the book. So the train is moving, rather accelerating, okay, to the right direction. It is just like, let me explain you in this way, that if you are sitting in your car, okay, you're sitting in your car and it is stationary. Once the car starts to move or accelerate forward, you will suddenly move backwards. है ना, ऐसा होता है ना कि when the car starts to accelerate, you just move in the backward direction. So this is the case being discussed over here as well. So if basically the train is accelerating towards the right side, then the book is going to move in the backward direction. Okay? And this can't be at a constant speed. Acceleration से ही you will move backwards. अगर constant speed हो जाएगी तो you will just sit on. ठीक है, तो इसका answer B है. That is accelerating to the right of the diagram. I hope you've understood the concept that as the frictional force was in this direction, so the motion of the book has to be in this direction, in the backward direction, and the train has to be accelerating in this direction. Okay? Constant speed or uniform speed पे it won't be moving. So I hope you understood the question. Interesting question. Just came in the 2023 paper. अच्छा जी, A cyclist is traveling in a straight line along a horizontal road at a constant speed. The constant driving force F acts on the cyclist in the forward direction as shown. Okay, which statement about the magnitude of the frictional forces acting on the cyclist is correct? The magnitude is equal to F. Okay, the magnitude is smaller than F but greater than 0. The magnitude is greater than F and the magnitude is 0. Okay. Here the key word is the constant speed, meaning when the speed is constant, so there is no acceleration. Right? Constant speed means no acceleration. So the driving force would be equal to the frictional force. If F would be greater, cyclist would accelerate and not move at a constant speed. So if the frictional force will be greater, the cyclist would be decelerating, है ना? If frictional force is greater, तो cyclist decelerate करेगा. If this force was greater than the frictional force, then he would be accelerating and not moving at a constant speed. So A is the correct answer, which states that the magnitude is equal to F. So frictional force has to be equal to F. So they are moving at a constant speed and there is no acceleration. Okay. Question number 3. A student measures the length of a spring. She then attaches weights to the spring. She measures the length of the spring for each weight. The table shows her result. What is the extension of the spring with a weight of 3 Newton attached to it? Okay. When the weight is 3 Newton, okay, so what is the extension? This is when no weight is attached to it. So initial extension या natural extension of the spring when nothing is suspended from it is 520 mm. So when a weight of 3 Newton is suspended from it, so the extension is 533 Newtons. So if you have to find the extension of the spring when the weight of 3 Newton is attached, so you will subtract the initial extension, that is 520 Newtons, from 533. The extension which is caused by 3 Newton force weight. So this is going to give you 13 mm. So D is going to be our correct answer. Okay. Question number 4. A metal wire is loaded up to limit of proportionality. Which statement is correct? Hooke's law is not obeyed when the load is increased from 0 to this point. No, this is not correct because Hooke's law is not obeyed after the limit of proportionality has been reached. So it hasn't been reached yet, so it will obey the Hooke's law. When the load is increased beyond the limit of proportionality, the diameter of the wire will increase. The load after the proportionality has nothing to do with the diameter of the wire. It has to do with the length of the wire. So option B is not correct. When the load is removed, the wire returns to its original length. Yes, option C is correct because the limit of proportionality hasn't been reached yet. Matlab it hasn't been crossed. So when the load will be removed, the wire will return to its original length. Up to the limit of proportionality, there is no change in the shape of the wire. There is a change in the shape of the wire up till the limit of proportionality, but that shape is reversed when the loads are taken off. So that is why option D is also not correct. Okay, question number 5. A tennis ball has a mass of 57 grams. A tennis player hits the tennis ball with a racket. A tennis ball has a velocity of 25 meters per second when it hits the racket. The velocity of the tennis ball as it leaves the player's racket is 15 meters per second in the opposite direction from its approaching direction. The average force exerted by the tennis racket on the ball is 35 newtons. For how long is the tennis ball in contact with the tennis racket? Okay. We've got to find the time in this question. Okay, we have the mass of the ball. We have the initial velocity of the ball. We have the final velocity of the ball. We have the force that is acting on the racket. And as this is the final velocity of the ball is in the opposite direction, like if this was our racket, so when the ball was coming in, it was coming in at 25 meters per second. The velocity was 25 meters per second. When it hit the racket and went off, the final velocity is 15 meters per second, and as the direction of the ball has changed, so one of it has to be negative. You can keep any one as negative. You might keep this as negative and this is positive, or you might keep this as positive or this is negative. So we might keep this as the positive direction and this as the negative direction. This is up to you. You can choose any velocity to be positive and any velocity to be negative, because this is up to you which direction you are taking as positive. Okay, so we all know this. Now when we see that all of this can give you, can be added to in a formula, and then you will be able to get the time. But we don't have the acceleration as yet. Okay, na? To find the acceleration, we need a formula, that is F is equal to ma. We already have the mass and we already have the force. So we can easily find acceleration from this formula. Now the mass has to be in kgs. It has to be converted to, so 57 by 1000 would give you 0.057. Okay, so let's put in the values. That is, the force is 35 newtons. The mass is 0.057 and the acceleration we have to find. So 35 over 0.057 is going to give you 614 meter per second square. So now we have everything that we need to calculate the time. Okay, so Vf minus Vi by T is equal to A. So this is minus 15 minus Vi. You can always use U and A as well. Okay, for final and initial velocities. I just use Vf and Vi for a clarity. Okay. Okay, so minus 15 minus 25 by T. This is going to give us minus 40 over T is equal to 614. So T is going to go there and minus 40 by 614 will come here. So our time is 0.0651 seconds. So C is going to be our correct answer. A little lengthy procedure. We had to find the acceleration first and then the time. Although all of this can be avoided once you've done and covered the topic of momentum, so you'll see that we can find all of this with a very simple formula, that is, just switch with the pencil. That is force is equal to delta P over T, where delta P is change in momentum, which is m Vf minus Vi initial velocity by T. Okay, so you would have also taken out everything from this formula as well. But abhi आप लोगों को momentum, I haven't done that with you guys, so I'm not using this formula at the moment. Okay, so let's move forward. Okay, now question number 6. A cart has a mass of 10 kgs. A boy pushes on the cart horizontally with a force of 50 Newton. The car accelerates at 0.50 meter per second square. What is the frictional force acting on the cart? Okay, now we know our formula, F minus F is equal to ma. So firstly, the force was 50. The frictional force we don't know. Mass we already know is 10. And acceleration has also been given to us in the form of 0.05. So this is going to give us 550 minus F, 50 over, 50 minus 5 is equal to F. The F is going to get positive. This 45 newtons is going to be our frictional force that is acting on this cart. So option D is the correct answer. Okay, question number 7. A car of mass 1200 kgs is traveling along a horizontal road. The total frictional force is, okay, what is the acceleration of the car? Okay, now we know that the mass of the car is 1200 kgs. The total frictional force is 1000 newtons. The driving force is 4000 newtons. So we can always find out our acceleration by our formula, F minus F is equal to ma. So we have 4000 as driving force, 1000 as our frictional force. Mass of the car is 1200 and acceleration is this. So 3000 by 1200 is going to give us our acceleration, which is 2.5 meter per second squares. So this is option C over here. So this is the correct option. Moving forward, question number 8. The diagram shows 3 forces acting on an object. What is the value of the resultant force acting on the object? Okay. Now 3 forces are acting on the object. As one of the forces is entirely in the different direction, these two could have been taken out. kg 9 minus 1 karenge, and this is going to be 8 Newton force acting on this direction, but we have a force in this direction as well. So what are we going to do is we are going to construct this like this. So what can we do is that we can just subtract 1 from 9. Okay. So 9 minus 1, that is a force of 8 newtons is acting in this direction. Okay. Because we can't take then 3 forces acting like this now. So as this force is opposite, so we can always find the net force by subtracting 9 Newton from 1 Newton. है ना? So disregard this at the moment. So 8 newtons force is acting in this direction, and then from the head of the first vector we can draw the second vector, which is of 6 newtons acting in this direction, and then we can always find the resultant force in this way. Okay, so we can use the Pythagoras theorem for this. Which is a square plus b square is equal to c square, where a is the base, b is the perpendicular, and c is the hypotenuse. Okay, ji, so our base is 8 square plus perpendicular is 6 square, and this is hypotenuse square. So 64 plus 36 is going to give us 100. And as we need hypotenuse, not its square, so this is going to give us 10. So hypotenuse or resultant is 10 newtons, okay, which is the option B over here. Okay, so let's move to the next question. A stone is dropped from rest at a height of 2 meters above the surface of the planet. The planet has no atmosphere. The speed of the stone just before reaching the surface of the planet is 3.8 meters per second. What is the acceleration of free fall on the planet? Okay. Asha, this question can easily be done by two ways. Okay. Asha, I'll discuss both the options with you guys. Just let me get my eraser. So we have some space over here to solve this question in both ways. Okay. Now you've not done, maybe you've not done this formula, that is Vf square minus Vi square is equal to 2As. Okay, where you know this is the final velocity, this is the initial velocity, this is acceleration, and this is the distance. Okay, so this is a very common formula, just like Vf square minus Vi square by T is equal to A. But this formula is at the moment not included in your course, so we are not doing it with this. Although if you know this formula, you can easily take out the answer with this formula. Okay, you can do 3.8 square, which is our final velocity. It has started from rest, so 0, to acceleration or to GS or AS. So this we have to find, and the distance was 2 meters. Okay. So 3.8 square is going to give you 14.44 is equal to 2GS. So this is going to give you 4G. So 14.44 by 4 is going to give you the value of acceleration, or this, which is 3.6 meter per second square. Okay. So this question can be easily done with this question. Okay. Now, when you are going to study kinetic energy and gravitational potential energy, I think it's after 3 or 4 topics. So you will understand one thing, okay? That whenever something is lifted against gravity, okay, so it gains gravitational potential energy. Okay. And then when it is again dropped, so this gravitational potential energy is converted into kinetic energy. Since we know that law of conservation of energy states that the energy can neither be created nor destroyed, it is just converted into another form. Okay? So what happens is that when something is taken to a height, it gains gravitational potential energy, and then when it is dropped, so this gravitational potential energy is then converted into kinetic energy. Okay, so the formula for gravitational potential energy is mass into gravitational force into height. Okay. And the formula for kinetic energy is half mass into velocity square. ठीक है? Since we are seeing that gravitational potential energy is being converted into kinetic energy, so they can be equalated. ठीक है? Now we see that we don't have the mass over here in this question. So the mass can be cancelled on both the sides. ठीक है? Now what we are going to do is that we have to find the acceleration of the free fall, that is g. We have been given the height, that is 2 meters. ठीक है? Then we have the velocity given here, which is 3.8 meter per second. So if we put this over here, so we can easily find the gravitational force. We will solve this. We will bring this to here, and this all the solution is going to give us 3.61 meter per second square. So you can use either of these two methods. This is the method 1 and this is the method 2 to solve this question. Okay. So this is how you are going to calculate the acceleration of free fall. दोनों में answer is going to be the same. Whether you use this formula or that formula. I think kids should know these formulas. Although this is not included in your course, so I can't just make you learn the formula. But this formula always comes in handy in other questions as well. If you know this formula, so this is going to come in handy to you. But this is the second explanation or the second method that I've mentioned. This is in accordance with your syllabus. So you can use this. And this, as it is in accordance with your syllabus, this is always a good option to use this kinetic energy and gravitational potential energy concept over here. Okay. It's a question from 2020. It might have been included in the course back then. You never know. Okay, na? I'm not familiar with the course outline of 2020. Okay, moving on to the question number 10. A mass of 20 kgs is held stationary by a rope passing over a frictionless pulley. Okay, what is the tension T on the rope? Acha, we will calculate tension. Always remember that the tension is always away from the object it is acting on. Always remember these small concepts, they come in handy while you are solving your paper. Okay, so at the time we have to calculate the tension, we know the mass. So what are we going to do is that we will use our formula F is equal to ma, but we don't have acceleration over here, so we can't use this. Okay, we has, and we had to find the force, but we can't use this formula. Okay, the first thing that comes into our mind is this formula, but this is not applicable over here. So what are we going to do is we will use the other formula that covers these entities that have been given to us. Okay, W is equal to mg. Now we have the mass. Okay, W is going to be our force as well. So W is equal to mass, which is 20 kgs, into G, which is 9.8, or initially it was taken to be 10, as you know. So if we will take 9.8, there will be slight difference in the answer. So here we are taking 10 as the gravitational force. Okay, so this is going to give us 200 newtons. Taking 9.8 is going to give us 196 newtons. So both you can use, and you will be able to see that 196 newton is, not this. 196 newton is very close to 200 newtons. So this is going to be your correct answer. But as it's a 2019 question, so the gravitational force value at that time was 10. Okay. So moving forward, Question number 11. A car is driven from rest on a long straight road. The car engine exerts a constant driving force. The diagram shows the horizontal forces acting on the car. The resistive forces are proportional to the speed of the car. Okay. Why does the car eventually reach maximum speed? Okay. Number A option states that the resistive forces decrease to make the acceleration of the car negative. Okay. The resistive forces decrease to make the acceleration of the car zero. The resistive forces increase to make the acceleration of the car negative. The resistive forces increase to make the acceleration of the car zero. Okay, now what is happening over here? We know that as the car accelerates, its speed also increases. ठीक है, we've established that many times. ठीक है, if the speed increases, the resistive forces acting on it increase as well. ठीक है ना, increase in speed is also proportional to increase in the resistive forces. We all know this thing also by now. We've done many questions that involve this concept. Acha, at some point, the resistive forces become equal in magnitude to the driving forces. Obviously, na? At some point, the resistive force is going to be equal to the driving force. Then constant speed would be achieved. So, this is going to give us, just give me a minute. Charge this. Okay. Now, when resistive force is equal to the driving force, these are forces that are equal in magnitude and opposite in direction. So, the net force on the car is also going to become zero. The car is going to move at a constant speed. Huh? The zero acceleration means the car's speed becomes constant and it has reached its maximum speed. ठीक है? Understood up till now? It has reached its maximum speed. Acha. Therefore, we can conclude that the resistive forces increases to make acceleration of the car zero. ठीक है? Resistive forces increase to make acceleration of the car zero. है ना? So, according to all of this which I've explained, D is the correct option, which states that the resistive forces increase to make the acceleration of the car zero. One would think that the driving force is going to increase, and that is going to give you the acceleration and all, but no, this is not the case. This is the case when a car accelerates, speed increases. When speed increases, resistive forces increases. At some point, resistive forces become equal to the driving force. The car is going to move at a constant speed. The net force on it is zero. So when we've established all this, we've reached the conclusion that the resistive forces in this case increase to make the acceleration of the car zero. ठीक है जी? Okay, moving on to question number 12. A box of mass 2 kgs is pulled across the floor by a force of 6 newtons. The frictional force acting on the box is 1 newton. What is the acceleration of the box? Okay, we can find it by our formula, that is F minus F is equal to ma. So this is the force with which it is pulled. This is the resistive force. Mass is 2 and already in kg. So acceleration is 5 by 2, which is 2.5 meter per second square. So this is the correct answer. Okay. Question number 13. A resultant force of 4 newtons acts on an object of mass 0.50 kgs for 3 seconds. What is the change in velocity caused by this force? Okay. Now, this is our force. This is our mass. This is our time. So, what is the change in the velocity caused by this force? So, we can find this with the help of the formula that I've taught you initially. That is force is equal to delta P over T, where delta P is the change in momentum, which is by T. Okay. So our force over here is 4 newtons. Our mass is 0.50. This is the change in velocity. Delta V भी लिख सकते हो आप यहाँ पे. And time for 3 seconds is given. So this is going to give us 12 is equal to 0.50. Delta V is the change in velocity. So 12 by 0.50 is going to give us 24 meter per second square, which is our acceleration. And D is going to be our correct answer. Okay. Moving forward, question number 14. An object accelerates from 10 meter per second to 30 meter per second in 4 seconds. The accelerating force is 150 newtons. What is the mass of the object? Okay. So this is our initial velocity. This is our final velocity. This is our time. This is the accelerating force, and we have to find the mass. So what are we going to do is that हम फिर वही formula use करेंगे. F is equal to delta P over T. Force is equal to mass Vf minus Vi over T. So force is 150 newtons. Mass we have to find. So 30 minus 10 over 4. So 4 into 150 newtons. Or we might do another thing as well. Mass 20 over 10 is going to give you 2. So 150 over 2. Oh, sorry. This is 4, not 10. 4 ones are 4 and 4 fives are 20. So this is going to give you 5. And 150 by 5 is going to give you the mass, which is 30 kgs. Okay. So this formula is very helpful. You are going to have it on your tips once you've done the topic of momentum, because it is going to be used over there like tons of times. So you are going to get familiar with this. Okay. So this is how you are going to do this question. Okay, now moving on to, okay, D was the correct answer. Sorry, didn't mention the correct answer. Okay, moving on to question number 15. An object decelerates from 25 meter per second to 5 meter per second in the time of 4 seconds. It has a mass of 50 kgs. Just give me a moment. Okay. What is the resultant force on the object? Okay, resultant force we have to find. We've been given Vf, Vi, time and mass as well. So we can do it in 2 ways. Okay, in 2 steps. Once we can find out, in 1 step we can find out the acceleration. Okay, and then put this acceleration into the formula F is equal to ma, and that is how you are going to find the resultant force on the object. Or you can do it in 1 step by using the formula F is equal to delta P over T. ठीक है, अभी चलो चलो पहले इस तरह कर लेते हैं, no problems. Okay, now we know that Vf 25 is our final velocity. We will use this formula for the time being. So, sorry, this is the initial and this is the final. It decelerated, na? So 5 minus 25 over 4 is going to give us acceleration, that is minus 20 over 4, that is minus 5, as this is deceleration, है ना? So when we will put these values in this, mass is 50. So we can skip the negative part, as it was deceleration. This negative part is just going to tell you that. So 50 into 5 is 250 newtons. So this is going to be our correct answer. And you can always use this formula to find this force as well. Okay? Okay, this brings us to the last part of, last question of this video. This part, we will cover rest of the questions in part 2 of the video. Because the video has like it's 26 or plus 15 minutes long, so it's quite a long video. Now we will cover the rest of the questions in the part 2 of our video. So see you then, inshallah. And if you find any of this helpful, kindly remember me in your prayers. Thank you and Allah Hafiz.